Welcome to this OST2 lecture about PCR operations using the TPM2 tools and the TPM2 TSS eSAPI. Here we have the list of all available PCR commands. There are three main operations that we'll focus on. The extend operation, which is the only write operation we can perform. The read operation, which retrieves the content of the PCR register, the hash digest. And the PCR reset command, which is used to clear the content of the PCR. Of course, the PCR reset will only take place if the strict rules are met. Then we have PCR event, which is a similar operation to PCR extend, where the TPM performs and computes the hash digest. TPM2 PCR allocate is a special command, and it is used to disable different PCR banks based on the algorithm. For example, if we know that we're going to use only SHA-256 PCRs, then we can safely disable SHA-1 banks, especially when the SHA-1 algorithm is deprecated. The last two PCR commands are PCR set out value and PCR set out policy. As the name suggests, this adds authorization to the PCR registers of our choice. The TPM2 PCR read tool implements the read operation. Without arguments, the tool will output all available PCR banks. This means SHA-1, SHA-256. Therefore, I recommend when using the tool to specify at least the algorithm for which we are interested. In this case, I've given an example with SHA-256, and here we can see 24 PCR registers. Most are zeros, the others are ones. These are the default states of these registers. Of course, we can select a specific register and not have all of the available banks for this algorithm shown. Here is an example how we can do that, specifying the algorithm, then specifying the register number. As we already covered, PCRs support different digest algorithms depending on what the TPM support. If a TPM supports SHA-512, then the PCRs should also support that. Usually, what we have as a minimum is SHA-1 and SHA-256, but of course, SHA-384 and SHA-512 are also becoming widely available nowadays. And the PCR banks coexist. This means that the SHA-256 bank and the SHA-1 bank are existing at the same time. And we can even specify using the PCR read tool to print the PCR register in both formats with the two digests. And as you can see, the value is different because they're different registers. Of course, there could be exception to that, so we have to be extremely careful when extending information that it falls in the proper bank with the right algorithm that we want to use, so we don't get the wrong data when preparing our status reports based on PCRs. And this has been described by Chris Fenner in a very interesting talk on tpm.dev, and he also has other publications related to what is known as TPM carte blanche. Here is the eSAPI variant for PCR read. As usual, we have to provide our ESIS context at first argument. Then we have the three authorization slots. Then we are making PCR selection. This is quite literally what this variable does. Select the types of PCRs we want, depending on the algorithm, how many of the PCRs we want, and which ones. Here is a nice example. Then we have PCR update counter, which usually provides the number of times that these PCRs that we're requesting have been updated. Then in PCR selection out, we have a list of the PCRs that were actually retrieved. This is good to compare with our in list here, PCR selection in, because sometimes for some reason the operation may not succeed completely, but it will still report the values that it can. And in this case, we would have to confirm that we have these three PCRs in selection out. And for the actual values, we have an array here that holds the PCR values for each of the PCRs that we selected. It is good to mention that PCR operations usually require no further authorization than having the proper locality level. However, we have the two commands I mentioned at the beginning to add out value or out policy to PCRs. Now that we can read a PCR, the next logical step is to perform a write operation, and this is the PCR extend. We have an easy-to-use tool, the tpm2_PCR_extend, to do this. Extending a new value into a PCR requires us to specify the exact PCR number and the type of the PCR by algorithm. There is one difference compared to PCR read. In PCR read, the algorithm was taking the first position in the argument and then was the number of the PCR. As we go down on our example here in the screenshot, after reading the PCR and making sure it's all zeros, then we compute the hash digest in the next command here with SHA-256-SUM. When we get to tpm2PCR_extend, we have to specify the number of the PCR first and then the algorithm, in this case SHA-256, and adding the hash digest that we want to extend into the PCR. And notice what happens when we perform a PCR read. The value here is a new digest, that is the concatenation of the original value of all zeros and the hash digest that we wanted to extend. This is an example of how the old content of the PCR is preserved, and the order of extending into the PCR matters, because if we have this hash digest first and then we extend with all zeros, the resulting value in the PCR would be different. Here is the eSAPI variant of PCR extend. At first place we have the ESYS context. At second space we have the PCR that we want to extend. Then we have 3 authorization slots, and last we need to provide the hash digest, and we can extend multiple digests at the same time. Here is an example of how this looks in C code. This is the last of the core PCR operations, the reset operation, the one we use to clear the content of a PCR. And remember, there are strict rules when this operation can succeed. Here we're going to use PCRs 16, the debug PCR register, and 23, the application PCR register, to demonstrate. The reset value of a PCR is defined in the TCG specification, and it depends on the PCR register number and its use. It's either all zeros or all ones. The value is reset, of course, to the full length of the hash algorithm for that bank. If we have SHA-256, this would mean 32 bytes of all zeros or all ones. And here is an example. We are reading the 23rd PCR register of SHA-256 bank, and here is the value from when we extended. Now we're going to reset this PCR register by simply providing the number of the PCR. This would reset the PCR in all banks, and when we check the bank for SHA-256 with PCR register number 23, we see that it has become all zeros. This is possible because PCR registers 16 and 23 are the ones that we can reset from any locality level. This is why they're usually used for developing and testing, and in some cases they're very useful for application purposes. We just have to keep in mind that there's a possibility for other parties to reset that PCR. So we need to make sure that when we're extending and working with that register, we are the only user at that time. And of course, we can try to add some authorization to this PCR register with the additional PCR commands. Here is the eSAPI variant for PCR reset. Quite straightforward command. We have the ESYS context, the PCR handle, which is just the PCR number, and 3 authorization slots, especially for the case where, let's say, we want to use PCR23 application PCR and we've added additional PCR authorization. A summary of what we learned in this lecture. These are the TPM2 commands available to us for using PCRs. Here are their eSAPI equivalents, and then here are the TPM2 tools available currently. What you can see is that the PCR set out value and PCR set out policy do not have their counterparts when it comes to TPM2 tools. However, all of the core operations PCR extend, read, reset, and even allocate are available to us, which is very useful for experimenting and developing an application later in eSAPI. The exercise workflow that we recommend for these labs is to first use TPM2 tools to get familiar with PCR operations and try out different scenarios. Then move to using our eSAPI template the same way we did for the previous labs, and start to add ESAPI PCR operations.